Hi there, I'm Ed James with the Carson Water Sub-Conservancy District, and I will be presenting a project that I've been working on since April of this year, looking at the various surface and groundwater data that's collected in the Carson River watershed. In the Carson River watershed, the Department of Water Resources and the Federal Water Master have been collecting groundwater and surface water usage for many years. This data that is collected is used by various entities to look at historic trends and for projecting future trends. With the help of Melissa James, we have gone through the historic data. In doing so, we have found some errors in the records. These errors have been presented both to the Department of Water Resources and the Federal Water Master to correct their data set. The purpose of this presentation is to present the findings. The goals of the project were: 1, to digitize the state engineer's pumping data and the Federal Water Master's diversion records and put the data into a spreadsheet. 2, correct any math or data entry errors that we found. And 3 was to estimate water use for the missing diversion records. To create this missing data set, I met with the various landowners to understand their historic irrigation practices and also looked at stream flow data. The Department of Water Resources publishes an annual groundwater pumping report for various groundwater basins. Some of the data goes back as far as the 1980s. The data is presented on a water year basis versus a calendar year basis. In the Carson River watershed, the Department of Water Resources publishes a groundwater pumping report for 4 of the 5 major groundwater basins. The 4 groundwater basins that have pumping reports are the Carson Valley Groundwater Basin, and this underlies part of Alpine County, the Douglas County, and part of Carson City. The Eagle Valley Groundwater Basin, which underlies mostly Carson City. The Dayton Groundwater Basin, and this one underlies some of Carson City, the Dayton area, all the way out to Mark Twain. The Churchill Valley Groundwater Basin, which underlies a lot of the Silver Springs area. The one basin that does not have an annual report is the Carson Desert Groundwater Basin, and this underlies most of Churchill County. For the groundwater pumping report, water usage is categorized into various manner of uses. They are miscible and quasi-miscible, irrigation, industrial and commercial, recreation, stock water, others, and domestic. The way these readings are recorded is either through actual meter readings, or for irrigation, it could be meter readings, or it could be an estimate of the net irrigation water requirement. For domestic wells, since they are not metered, the state engineer assumes 1 acre-foot per dwelling unit. For this project, we only analyzed the immiscible and quasi-immiscible data. The reason we did this, we were able to contact the various water purveyors and actually get their actual production that they did each year. The slide in front of you shows you how the data was set up in the spreadsheet. On the far left, you have the application number, then you have the manner of use, then the given years from 2002 to 2017. Each of the cells has data that was taken from each of the groundwater report. The cells that are highlighted in yellow are where we found either mistakes or inconsistencies in the data that was in the report. In all, there were over 10,000 cells that were developed and analyzed in this study. This slide shows the calculated pumping compared to what was reported in the state engineer's pumping report. On the far left, you have the different water purveyors. You have what we calculated, then you have what the state engineer reported, and then the difference between the two. These spreadsheets have been provided to the Department of Water Resources and can also be found on CWSD's website. There are also a README file that talks about what the errors were, and there are notes that also clarify what was changed or modified in those reports. We will now focus on the surface water. The Federal Water Master records diversion data throughout the entire Carson River watershed. This analysis is only focusing on the lower Carson River. The main reason is that all the ditches, from the Mexican ditch all the way down to the Buckland ditch, are actually recorded. In the upper watershed, from Alpine County through Douglas County, not all the ditches are recorded, and it's much harder to calculate how much water is actually being diverted out of the river because of the complex nature of the upper watershed. The slide in front of you shows you the various ditches that take water out of lower Carson River reach. There were other ditches that took water out of this area, but over the years they were either combined with the list in front of you or they ceased operations prior to 1978. The Rose Ditch and the Dayton Ditch ceased operations. The Rose Ditch stopped diverting in 2004 and the Dayton Ditch stopped diverting in 1989. These water rights were transferred to municipal use. Also, many of the ditches shown here have had their water rights transferred out, so they take less water today than they did historically because of the water transfers. The slide in front of you shows how the Federal Water Master records their data for the various ditches. This is for the Mexican ditch for 1998. What the Federal Water Master would do is go out periodically and take a stream flow measurement in the ditch. They would then average those stream flows in a given month to get a mean flow rate. They would then multiply that by the number of days in the month and then multiply it by a conversion factor of 1.98 to get from CFS to acre feet. You can see in July that the mean amount is 49 CFS. However, if you multiply 49 CFS by 31 days and by the factor of 1.98, you will not get 1,263 acre feet, but instead a little more than 3,000 acre feet. These are some of the errors we found in the data set. You will also see that there are several zeros with S's next to them. The S means stock watering. What typically happens when a farmer takes stock water is they divert water out of the river, keep it in the ditch so the cows can drink from it, and then the water flows back into the river. This is considered a non-consumptive use and not considered as water being diverted. However, as we get further on, we'll see that not all of these S's are a correct indication of how much water was actually used for irrigation. This slide shows the spreadsheet that was developed for the Ghee ditch. You will see the years from 1978 to 2015 and each of the month, and then you will see an acre foot and a CFS that was recorded for each of those months. This data was taken directly off the Federal Water Master's diversion records. You'll also see some of the cells that are highlighted in yellow. These are the cells that we found math errors that we will address later on. The other cells that are shown in blue indicate that these had stock watering and had a 0 for a flow rate in those record sets. You will notice in 1997 there are two data sets. One includes the stock watering at 0 flow, and the other showed an actual flow rate in the ditch. This data set was developed for each of the ditches for the lower Carson River water. This slide shows the spreadsheet for the Mexican ditch. Like the Ghee ditch, this data was taken right off the Federal Water Master's diversion records. The yellow cells indicate where we found math errors, which we'll address later on, and the blue cells show where zero flows were indicated with an S next to them for stock water. This slide is the same as you saw earlier. However, this time we correct the math errors and they are highlighted in red. We call this data set the edited Federal Water Master data. This slide shows the last spreadsheet that we developed, what we are calling the CWSD diversion records. What we did was we incorporated all the math errors we saw, but then we also looked at the actual diversion records. One of the things we found is that from 1995 through 2005, the diversion records for all the ditches showed a lot more stock water with zero flows than what were recorded earlier or in the latter years. This seemed to be inconsistent with the data sets. So we went out and we met with each of the landowners to find out how they historically irrigated and their current practice and see if there were any changes. What we found from them is that they typically would take water in as April as soon as possible and run water through the ditch for irrigation. Rarely, if ever, they would actually run water through a ditch for stock watering during the irrigation period. Based on this conversation, we went back and we looked at all the data that had zero flows with stock watering and actually put in a flow rate that we believe would most likely occur based on the flows in the river. This became a new data set that we created. We also went through and looked at all the missing data sets and tried to recreate those by looking at the historic practices of the ditch and the stream flow at that time. This created a data set that we believe probably is more closely indicating what actually was diverted out of the river. Now, this may not be a data set that all researchers would want to use, and we would strongly recommend that if they are using the actual data from the Federal Water Master to calculate trends, that they would look at this and come with their own conclusions on how much water they may have been actually diverted during these periods. But this would probably give you a more accurate indication of how much water was diverted historically than just using the raw data. This graph here shows the three different data sets that we talked about earlier. The blue is the raw Federal Water Master data. The orange is the corrected Federal Water Master data, and the gray is the CWSD's data set that we created. You can see that the trends follow each other fairly closely. In fact, they're on top of each other most of the years. However, in 95 to about 2003, we do have a slight change based on the stock watering calculation. This graph is a combination of all the ditches in the lower Carson River. The orange is the raw data from the Federal Water Masters. The gray is the edited Federal Water Master data with the math errors corrected. And the blue is the CWSD data set. Now you'll see that there is a big difference in the early 1980s between the CWSDs and the raw data. And the main reason for those differences is that there were a lot of missing records in some of those years that we went back and tried to recreate. So that's why you have such a large differential between the Federal Water Masters, raw data, and CWSDs. From the 95 to 2005, the difference has to do mostly with stock watering and how we calculated diversions to the stock water. You can see, though, the overall trend has been a downward decline by all three data sets. This graph shows that from 2000 forward, the amount of water being diverted out of the lower Carson River has been reduced significantly than compared to historic diversions. This is because a lot of the irrigation water rights have been transferred to M&I use. The Rose and the Dayton ditch no longer divert water, and the Mexican ditch and the Cardelli ditch irrigation lands have been reduced significantly over the period of time. This trend may continue in the future. Conclusion. First, we want to thank the state engineer and the federal water master for the great job they do in recording the water usage. If it wasn't for their efforts, we would not have this great data set available to do historic trends or modeling projections. It takes a lot of time and effort to actually collect this data, and we appreciate the time and dedication that both these entities provide us. Second, if you're going to use the historic diversion record or even the groundwater records, you need to evaluate the data set you are going to use. Third, understanding that irrigation will be impacted by other factors besides water availability or ET. When we met with the different landowners, we found out that over the past, there may be other things that impact how much water they can physically divert in a given year. Melissa James has prepared a memo going through the surface diversions and also talks about some of the information we found from the individual landowners. This memo and the spreadsheets are available on CWSD's website. Thank you for your time. Are there any questions?